Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through some of the major topics facing importers and manufacturers in China today. Hello there, listener, and welcome along to episode 12 of the podcast. We continue our exploration of how to vet new Chinese suppliers, and in this episode we're looking at how to evaluate their engineering capabilities, which is particularly important for anyone who's planning on developing their product as well as manufacturing it for launch. Now, without further ado, let's hear the conversation.
Hi Renaud. We've already discussed the dangers of finding the wrong supplier and some of the initial sourcing approaches for when you're vetting new suppliers, some of the questions you need to ask, some of the tips that you've suggested that can really help source good suppliers in China. And now we're moving on to checking a supplier's engineering capability. So this is the next step. So can you talk to me a little bit about that, please, Renaud?
Hey, hi, Adrian. So yes, a lot of our clients develop their own products. So this is really a key point for them. And we'll focus mostly on electrical and mechanical products here. If you develop your own product, at one point you need to have the manufacturer, do something. So in some cases, you might work with a design house, and you might hire your own team to do pretty much all the design. Okay, so a designer might do the aesthetics, the drawing of the outside. A mechanical engineer might work out, for the casing and maybe some other parts. Exactly what it's going to look like, and into the details to do the 3D CAD drawings. And then if, for example, there's some electronic parts, you need to do the electronic design, to pick the components, to do the schematic, and to get to the Gerber files and all that kind of stuff, and write the firmware. So there's actually a lot of work, especially with complex products. If they're really new and complex, with some really new features or a lot of features, or it can get really complex. So some people actually do all of that on their side before even starting to talk to potential manufacturers. And there's some pros and cons of that, obviously, but most companies, will complement that with giving some of the work to a manufacturer. So, for example, they might do maybe the mechanical side, and maybe the user-facing side. Maybe a mobile application and something like that. They might keep that in their hands, but maybe doing the electronic design might be something they want to give to a specific manufacturer. Okay, or maybe there's something really very specific. They need a very specific kind of camera, or very specific kind of battery, or something like that, and they need to go and get the expertise with a manufacturer that really has these competencies. And we basically in our work of advising these companies, very often there's a mixed approach, right? Maybe someone on our team might do something, someone on their team might do something, and then a manufacturer might have to be brought in actually relatively early to provide some of the design and some of the engineering work. So why is it important to pick the right supplier for that? Well, obviously you want to pick the right manufacturer to do to get production right. Obviously, now if you also need the manufacturer to be able to do this work, this engineering work, yeah, don't pick the wrong supplier. We've seen a lot of really bad cases where, and this sort of leads back to one or two episodes before, with all the ways that importers get disappointed, let's say, by their suppliers in China, in Vietnam, in Malaysia, and so on. Well, maybe they picked the wrong company that has the wrong capability, or that has the wrong incentives, the wrong business model for them. Let's get that out of the way really quick first. If 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 your project is not very big and you go to $1 billion manufacturer, it's going to be nothing for them, except if it really fits into the maybe the latest strategic initiative of their CEO. But that might get reversed after 6 weeks, so don't get carried away. And another thing is, they might get excited, they get moving, but after 2 or 3 months, well, they're on to the next shiny thing, and that's it. They just drop your project, or it gets so slow because you are not the first priority anymore of the team. You are the number 4 priority. It gets so slow that it's like, it's death by 1,000 cuts. Is that what they call it? It's killing you slowly, but you always think, if I start from scratch now, I go back so much in time. And then 2 months later, you think, if I had gone back and started from scratch, at least I would have something, but now I'm still nearly at the same level. So you really want to avoid that. And then there's the capability issue, which is another kind of issue. Yeah.
Okay, so now we know why evaluating a supplier's engineering capability is so important in order to find a partner that's going to be really suitable. What are the kinds of attributes of this supplier that you should be checking then?
So, as I said, first the size and the let's say the general incentives and the time scales. I already mentioned all that. Also, the business model might really really play a role. If they are an ODM company, you go to them because they already developed this kind of technology, and you think, well, I just need to use their module for that, and you just need to adapt it a little bit. Sometimes it works really well. And sometimes they say, oh, well, this is an interesting product. Yeah, okay. And then they do the engineering based on your design direction, and and you give them a lot of good ideas. And then they say, well, yeah, we have some issues, whatever. And then it never goes into production. And what happens is, yes, it does go into production, but for their other customers, right? Because you might only give them 5,000 pieces for the first order. Well, one of their current customers is willing to give them a 50,000 pieces order. So it's, sometimes they don't think very long about these kind of things. So make sure you work with a lawyer to at least address the few big risks, and the problem is that many of these suppliers will not sign a contract, even if at that point in time they don't intend to cheat you. Well, they think, hey, there's really not many companies that they can find who already have that kind of technology, and I already gave them an interesting deal. I'm not going to sign a contract and take all kinds of liability and everything. That might not be a dishonest thing to do, but at least if you boil the contract down to just a few terms that are really important, do they still not want to sign it? Okay, that's really bad.
So if this particular supplier has quite a specific expertise that you need, and they know it, and that's why they don't want to sign a contract, because they feel that they've perhaps got some sort of hold over you.
Yeah,
of course, perhaps it's not wise not to sign the contract and to go ahead. So in that case, what would you advise doing?
Well, it depends basically how much risk you want to live with and how much control you want to have over the situation.
Mm.
If it's really not acceptable, then you need to find a way to develop the technology without them. So maybe you keep looking for another one. Maybe you find something that is already fine, so you don't need to work with that company to develop something for you. Maybe you can just reuse their standard modules or components. So it's more like a sign this contract, I buy it, I don't need anything special from you, I don't need you to do any work.
Mm-hmm.
It's a little bit easier to negotiate things in that case, or just redevelop it
Right.
from scratch. I mean, it can be painful, but in some cases that's needed. Or simplify your product and think of that for version 2. That's what, a lot of people don't think about that, but
Mm.
if you I mean, don't multiply your risks and expenses and everything just for that. So that's the danger of the ODM factory. If you cannot live with that kind of risk, if you need that level of control, then maybe you go with an OEM factory that will do some of the investment themselves and everything. But that's really only viable if you have really relatively large orders, and if you still have to put some of the money down usually, or go with a contract manufacturer, a design house and a contract manufacturer, and take things sort of from scratch. Well, that means you really don't rely on anybody. Maybe that's really the one thing that you want. But
Mm.
again, it might take you 18 months or more to get it to market. So maybe you want to do a first version 1 simple, and sort of in parallel start to work on the really more ambitious, more complicated one. The first version will give you a lot of feedback on what the market wants and likes, and will start to maybe get your brand name out there, maybe get you some distribution deals and so on. Don't try to go for the super expensive stuff, except if you're really a big company, right? So
Mm.
all that to say, again, it's do your homework, think about this carefully, and there's a lot of things to look at. Now, when it comes to the capability of actually doing the work, there's a few things, and I covered that in an article from a few years ago. Well, first, the format of the CAD files and everything for the mechanical drawings. Just make sure you can actually, if you do some of the work on your side, make sure that they can use the same software, or that at least it can be easily exported without losing anything important. Okay, that's a really a basic one, obviously.
Mm.
But then, if you need them to work on a relatively complicated product, you you need them to have basically good engineers. Okay, so if we break it down, let's just take the 4 types of engineers. Let's say mechanical engineers, electrical engineers, electronic engineers, software engineers. And I'm assuming sorry, I'm assuming that you will do a lot of the design, the user-facing design yourself, or with people maybe in your country. That's usually what most companies try to do. So mechanical engineers, well, they have to start basically from the aesthetic design, and then think, well, how, for example, for the casing, for the enclosure of the product, or maybe some functional components, some moving pieces and such. They need to understand how it's going to work. They need to be able to do some calculations for the strength, the torsional stress, and all these kind of things. I don't want to go too much to the details here. And some of the most common software can actually help them do simulations. Can they actually do simulation? If you have a guy who says, oh yeah, I can open this, look, I have the software, I have the CAD drawing. I can move it around. I can understand how it is. That's not engineering. That's just playing with software, right? So based on that, can they actually think, of the manufacturing process? How is this kind of design going to impact on manufacturing? What kind of issues might happen? So they need to have an understanding of the materials and of the processes, right? So, for example, a lot of the casings are in plastic. Well, they need to understand, PVC injection molding is a little bit more tricky than PP or ABS. They need to understand, the impact of wall thickness, the impact of certain geometries on actually the way the material will get into the mold and the temperature, and how basically all the physical and chemical aspects of the process, right? Because there's a lot of these things when you do a good DFM review, design for manufacturing review, you can pick them up. But if you don't do this kind of review, if you have a really junior engineer who doesn't really understand the material and the process, ouch, there's a lot of risks that they're not going to put their finger on, right? So again, understanding the impact of the design, being able to actually do the 3D drawing into the details, doing some simulations, sometimes quite useful, and really seeing the risks, pointing to the risks and coming up with solutions.
Okay, so in your dialogue with the potential supplier, then you're probably quite quickly going to be able to see whether they clearly do understand these different risks and understand your needs in a quite detailed way, and are also able to give you thorough advice, like around design for manufacturing and the rest of it.
Yeah, show me an example of a product that you guys designed recently. It's still fresh in your memory. Okay, so what kind of changes did you make to on the request of the customer, and why, and what were the changes? What were the risks coming with that? And also, what kind of changes did you suggest just to prevent some defects and some various issues in manufacturing? Well, if they have nothing to say, that's if the design is not very, very simple, at least, of course, they should have something to say.
Sure. Those are good questions to ask.
Yeah. Also, something very, very important is you might be in front of a project manager who knows everything and who's really good and very technical, a lot of experience. But that guy is following 10 projects. He's not going to be, he's following the number one customer. He's not going to follow up on your project, except if it's really, let's say, significant in terms of business outcome for them. And you need to understand that. How are they set up? How many projects are they working on? How many engineers do they have? With what kind of experience? Because the problem is, and that's really due to the nature of R&D projects. Very seldom would they say, okay, these 2 engineers are going to work full time on this project for 6 months or something like that. There's a lot of people managing, and then there's people doing some of the work, where they really share the resources as much as they can, simply because different kinds of problems, different technologies, and so on, will require some of the experience of the different members of the team. So it's better if you have a wider team to sort of distribute these resources among the variety of projects that you have. So what that means is, if the 3 biggest customers come up with a lot of engineering work, well, they're going to get it in priority, and it's going to impact you because it's going to put on the resources you were counting on, right? So try to gauge how busy they are. You say, oh yeah, so busy these days, and so on. Well, don't expect first grade sort of service, unfortunately.
Right.
Okay, but that I covered mechanical engineering, but electrical engineering, for example, how to calculate the motor torque and speed of a motor, if it includes a little motor, for example, maybe the machinery, the control systems, and so on. Some kind of products really require a lot of competency, a lot of depth in these fields. Electronic engineers, the PCB and all the components that go into it, and how to assemble it, and all these kind of things, the schematics, and working into the details. Well, that's good, but maybe if, for example, the product has Bluetooth or Wi-Fi, sort of connectivity modules, and it's going to be sold in the US. Well, what about FCC? Do they know actually how to design the PCBA so that the way the different components are laid on the board will allow for an easy pass? Do they have a concept of that, right? Or maybe after a fail, are they going to be able to maybe make some let's say, think about it deeply and understand the way it actually failed, and then make some changes to increase the chance that it passes after that, right?
Sure.
And obviously the testing, right? How to do the testing of the PCBA, quite important. Software, so there's some firmware. Pretty often with electronic products, basically there has to be some firmware. Who's going to do it? What kind of environment are they used to? If you start to do a little bit of the firmware yourself in your team, can they work? Is it very standard sort of language and environment? Then it's fine. They can probably do the handover easily, or maybe not. So, can they show some examples? What kind of features? What kind of what kind of maybe sensors and other specific components did they work on, right? In all of that, you can also ask, hey, for the proof of concept, the very early prototypes, do you have experience in actually speeding things up? Maybe using an Arduino component for the electronic side. You don't want to use that in production for various reasons. It's going to be, maybe consuming a lot of power and so on. But for the proof of concept, just making sure that actually can work together, your product can do these features. Do they actually have some experience putting things together like this in a rough prototype? Same thing for the mechanical side. Well, can do you know how to make maybe 3D printing, maybe molds in silicon for the plastic parts, maybe whatever, for this specific product, do you have some ideas? This is the kind of questions you can ask, how to make a really rough prototype. Oh, you would CNC it, okay, why? Why not 3D print it, and what's the pros and cons, and can they actually explain these kind of things, right? So all of this is on the sort of the R&D side, how to do the design and engineering all the way to get to a final prototype that is approved. But you also need them to help. I already mentioned certifications. Great, they've got to help for that. Then it might require redesign at some point. I mean, it's much easier if it's done well the first time. You also need them to help for the tooling, which is often a very expensive part of the whole project. They might not do the actual design of the tooling, but it would be good if they could actually review it, okay, and do they actually know how to do these kind of things, and have they done it in the past? Can they show one on their computer, or do they just trust the mold fabricator outside who will play his own magic? And then if you're not lucky and on your project it doesn't really, the magic doesn't operate, then nobody can help you actually fix things, because it's sort of the tool fabricator, right? And obviously, when the parts are made, some of the parts are custom made. Or if some of the parts are custom made, I should say, and some of these processes are maybe not very mature, well, there's going to be technical issues. Something extremely common is the surface treatment, the plating, the anodizing, the painting, whatever. There's very often, let's say, difficulties to match the really nice finish that the customer really wants and likes. Well, can someone actually go on site and look at things? So this is becoming more into the realm of quality engineers. But if you have some good process engineers, yeah, they can look into it and help. Same thing for assembly. The parts are going to come in. Hopefully they're going to do a pre-production pilot on a small quantity. Well, who's going to be there to actually look at the issues and track the issues and fix them and decide, well, this is still not good. We do not give the green light to go to production. We're going to do it again because we need to make sure they all works fine, right? So, and the issues can come from anywhere. It can come from the incoming components, very, very common problem in China, incoming component quality. It can come from the testing stations, maybe, also a common problem, especially for electronic products. It can come from maybe the assembly methods and fixtures. It can come from many ways, from many sides. Let me see. Am I forgetting something? The various, design reviews and process reviews and and things like that. Yeah, reliability testing actually is, does someone have experience with reliability testing? With highly, what is it called, highly accelerated lifetime testing. When you put the product in a very sort of an extreme environment, moving the temperature and humidity up and down and keeping it running and maybe doing some drop tests and vibration tests and simulating the use of the product for for like 2 or 3 years usually, or however long the warranty is, or let's say the general promise to the consumers is. So does someone have a bit of experience on that? Because it's a great way to catch the design issues on a new product. And if they are not even aware of that, wow, you're definitely not working with a first-rate organization here.
Okay.
It's really not common, let's say, for textile, okay, but when you go into electrical products, wow, and mechanical products, if it's a new product and you intend to make it in a certain number of a certain volume, it becomes sort of a must, especially if there are potential safety issues, something that users get in their hands, put in their mouths, whatever. They really count on it. It's really, really important. Yeah.
So you spoke about finding a very first-rate supplier, and a lot of these things that you've been speaking about so far, if it in an ideal world, the supplier would be able to provide all of this knowledge, all of this expertise, the ability to do all of the reliability testing, and be able to assure.
Maybe not in-house. They might not have the lab in-house to do it, and that's fine. There's, in China, especially in China, there's a lot of labs who can do that. No worries. But we're more talking about having people who actually have the experience, and the capability to understand how to do it and what is actually needed for this specific project.
And would you say the best way to assess this, because at the moment it's quite difficult for foreigners to travel to China, of course. So if you're trying to assess this remotely, the best way is just to ask those questions and ask for examples.
Yeah. Basically, yeah. Do a well, it's a bit tougher without being on site, but ask some questions and see. But yeah, of course, it's much easier when you're on site and you can see the different people and you can see, well, this guy gets it, this guy doesn't get it, and so on. Of course, yes. Yeah, I mentioned the quality lab a little bit. The testing equipment and so on. It's always better. Bigger companies would always tend to have bigger labs. That's great. But you can expect, at least if they can make some, the prototypes, there's going to be some benches and maybe some soldering stations and things like that. Something maybe for an area for a drop test, the equipment to do vibration test. This kind of stuff is really basic. If they don't have this, it's a little bit worrying, I would say. Yeah, basically that's it. I would say it's always project dependent. So if your project includes a certain technology or a certain material, obviously ask questions about that. Ask to see if they have some experience about it. Ask about examples of products that included those. Same thing for the packaging. Maybe you want a very fancy packaging, very specific. That's great. If they can show you that, obviously it's always a plus. And yeah, that's what I would say. The understanding of your quality standard. Well, we're going a little bit further away from the engineering capability here, but if they tend to work for a certain kind of customer with a certain quality standard, and you are either way below or way above, it's going to be painful. Try to get a sense of what their number one, number two customers are doing, and what kind of requirements they have and everything. And this will give you actually a very good insight into, hey, this is this is what these guys have been trained to do, right? And if it's very far away from what you need, it's a little bit of a red flag. It's going to be painful.
Right. Okay. Yeah. Good summary at the end there about the sort of questions to ask, and also ascertaining of the level of the supplier. Are they in line with where you're at? I think that's really important. So yeah, that was covering checking on the engineering attributes of potential suppliers and making sure that they're right for your project. Thanks, Renaud.
Yeah, cool. Thanks, Adrian.
Now, if you enjoyed today's podcast, don't forget to like, subscribe and share. You can find us on Apple Podcasts, Spotify and anywhere else that you get your podcast material from. Until next time, we'll see you later.